Hello everybody. Today we're going to work on quantitative data and how to build frequency tables, histograms, and box plots. So let's get going, shall we? First, we need a data set. And like always, I copy this data set to a clean file to play around with. All right, so we're going to work on quantitative data. You see we have a few quantitative columns. I'm going to work on age. Now at the same time, so first of all, let me label this raw for my raw data set. And I'm going to have this to be my histogram 1. What do I mean by that? Well, let's go to the raw data. Let's pick gender and age. Bring that over and paste it. 1, 2, 3. So what I have here is gender and age. What I want to do is build a few things. First, I want to build a histogram based on age itself. Now, when you build a histogram, a frequency table comes for free, and I'll show you what that means. First, there are quick ways to build pictures. So we can highlight all the data you want. Let's say we do it regardless of gender right now. We just want to build a summary picture when we have quantitative data. That is a histogram or box plot is what I would use. So you highlight your quantitative data, age, you go to insert on your Excel, click on recommended charts, and it should provide you some options. There are a few that are not useful, but every now and then one comes up that's really good, like the histogram. Beautiful. Or if you don't like the histogram, you wanted something more special, you can click on all charts, and you can see in all charts there is a box and whisker plot. So let's start there. Box and whisker plot. All right, so what we have here is our box plot of our data set age. So let me change that title to age. All right, so we have this age box plot. So what's in a box plot? Well, what's in a box plot is, first of all, you have these two dots. Those two dots are what Excel are looking at as outliers. What are these values? Well, let's check it out. If I wanted to see outliers, what I would do is I would take A and B, or whatever columns of data you had. I would go to sort, custom, sort on the quantitative variable, age, smallest to largest. In this case, the outliers are higher, so I'm going to go largest to smallest. Sorting is a very important tool. So I'm adding a tool that you should have worked on prior to here. You should learn how to sort and how to filter. So sorting is a great tool. Sort largest to smallest. And I can see right here, there are two numbers that seem to be outliers. The male is 77 and the male is 74, because those are what those two dots represent right there, the outliers. All right, now what else do we have? We also have our maximum according to Excel without the outliers. And what I'm trying to do is I will bring up information. You can see you could click on axes titles if you like those, but we also could bring up data labels. I like to click on data labels, and you can get more information you like on data labels and where they are labeled and more options. I like to the right so I can see them. So if you notice, click off, no chart element. Click on the chart, go to plus, data labels. Data labels are very important, and they allow me to label the points in my box plot. And what you see here is I see the 2 points that Excel is calling outliers. So we can investigate them to see if they're officially outliers, yes or no. What's more important is the values that Excel has highlighted here. We'll talk more about them later, but what you have is you have a maximum according to Excel, 73, once they cut out the outliers. So there's their maximum in the data set. You have the minimum in the data set. If we scroll down, the minimum in this data set would be 21. So we have the min, we have the max. So you can see where those numbers are coming from. What are these numbers? Well, these numbers represent the quartiles. That is, this is quartile 1, this is quartile 2, this is quartile 3. Let me write those down. So what I'm talking about here is when you have a box plot, you get what is known with this, the 5-number summary. And the 5-number summary is 5 numbers: the minimum, quartile 1, the median, quartile 2, and the maximum, these 5 numbers. The minimum is the minimum number in your list. We should know what the minimum is. The maximum is the maximum number in your list. Understand, Excel took out 74 and 77 as outliers, and so they are treating 73 as the maximum. The median is the middle number. If this set is odd, the middle number will be the average of the 2 numbers in the middle. That's why we're getting 43.75, I'm guessing. What we probably should do is have another number, n. N would be the count. All right, whenever I use the letter n, it represents count, sample size. So I can scroll down here and I can look at sample size quickly. And I can see I have 266 numbers in my data set. All right, we have 266 numbers in your data set. We're eliminating the 2 outliers. Let me highlight them using the font yellow as outliers. And so what I have here, since those are outliers, I really have 264 numbers in my data set. So that does mean that's an even data set. The median would be, there is no median per se because it's an even data set. You would have to cut the 2 numbers that are in the middle and average them. And that's where you're getting the median. Please look up the definition of median to see how they get that number. Now, quartile 1, what they're going to do is once they've figured out the numbers in order, the quartile 1 is the cutoff for the bottom 25%. That's really what the quartile 1 is, the cutoff for the bottom 25% of the data. So they went to the 25% point. So imagine lining your numbers up in order and making a cut at the bottom 25% of the data. When you're looking at a 264 equals 25% of that, this number, the lower 25, the lower 25th would be at the 66th position. So the number roughly in the 66th position would be the 25th percentile. And so that number, according to my data set, according to my box plot, is 37.356. Quartile 3, that's mislettered. Quartile 3 is the number in the top 25%. So this would be the number that when you take the data and make a cut, make a slice in your data. So if you think of your data on a number line and you wanted to slice the data at the point that separates the top 25% of the scores to the bottom 25% of the scores, what that number would be quartile 3, and that's number 52. So number 52, and these are ages. So now that I've written them down, and these come straight from my box plot, okay? If you notice, I'm just writing the numbers from the box plot. Minimum, quartile 1, median, quartile 3, maximum. Please look at the definition of these to make sure you're clear on what these mean. I mean, I've already built the box plot. So we've already built 1 out of the 3 things I wanted to build today, the box plot. The box plot is easy to build. Highlight the data, click on box plot, and you're done. And what you want to do now is to understand the box plot. That's very important. It's more about understanding this plot because plots are easy to get to nowadays. You want to understand where the numbers come from as you discuss these pictures. So these are the numbers in the pictures and what they represent. The minimum, you should understand, is the lowest number in the data set. So that's the youngest person in my data set, 21 years of age. 73 is the oldest person in my data set. Again, forgetting about the outliers. The average, not average, let me be careful. The median be the middle age, the median age in my data set is 43. The average actually is shown right here. The average is 45.029. The average is right there in here so you can see it. Notice the average is slightly above the median. What we have though is we also have the quartiles. We have quartile 1, 37. What that tells me is the bottom 25%. If you want to be in the youngest 25% of homeowners, you want to be 37 or younger. If you want to be in the top 25% of homeowners for age, you would be 52. You really have to understand your data set to understand what it means to be quartile 1 and quartile 3. To me, it's just a way to cut up your data set. It's positions. Who is the youngest? Who's in the bottom 25% or the youngest 25%? That's the 50-50 spot, right? 50% of the people are younger than 43. 50% of the people are older than 43. And quartile 3, that's the 25% marker. The oldest 25% of the data are 52 years and older. So again, we can explain what the box plot means. That's really, really vital to us. Now notice I brought the gender over. See, I brought the gender over because sometimes, yes, you have the idea of the age, but sometimes you want to focus just on a particular variable inside of the age. You want to filter. And the way I filter when it comes to pictures is, once again, I sort. Notice on the home screen, I went custom sort. Now, instead of age, I'm going to add a level. I'm going to bring that up to the top. I'm going to move. Where is it? It is copy level. No, move up. There we go. Move up the level. Beautiful. So sort by gender, then sort by age. Sort by gender, then sort by age. Boom. So I get all the females together. That's important because when I build a box plot, I'm going to highlight all the female numbers only. All right. So I'm going to scroll down and get to, oh, too far, female numbers only. And then I can insert recommended, see what they offer. They do offer the histogram again. We're not there. I'm doing the box plot first. Box and whiskers. Here you go. Click OK. And what I have here is female age. And so now I can cross compare total age of the neighborhood, because this survey is about homeowners in a neighborhood. And so we have the age breakdown in general, and then we have the female responses to my survey in general. Of course, I like to, again, add data labels to the right. And so I can see the breakdown, and then look how easy it was for me to draw the picture. And now that I've drawn the picture, I can now spend time discussing similarities, comparison, contrasting, looking at the similarities and differences. So, and the great thing about the box plot, right, I can write the information down. So this is the general information, and now I'm going to add the female information. Notice there is no outliers. Outliers are represented by dots. There are no outliers in the female box plot. And so the female box plot, we have a minimum of 21. We have a quartile 1 of 37.18. Let me go 2 decimals around carefully. Median is 44.90. The quartile 3 is 54, and the maximum 71. So, and then I'll move this picture down here, so I have it here. So now I can look at this and I can compare, right? The minimums are the same, maximums are slightly the same. I mean, overall, these numbers are pretty spot on. So the general and the female are very, very similar, not much of a contrast in their pictures. They're both what I like to call pretty symmetric. There's not really that much difference between the bars and the shape of the rectangle inside. That's what I look at. The shape of the rectangle is pretty much evenly spread between quartile 1 and the median and the median and quartile 3. I look for that spread, and then I look for the spread of quartile 3 to the max and quartile 1 to the min. I look for these spreads to look for symmetry. If I see one tail too long, I know I'm going to have a skew in my data set. So right now, without the outliers, we do not have a skew. But if you added the outliers back in, this whisker, as they often call it, this whisker becomes too long. And so what that means is we have a tail to the right. Your tail is heading towards the larger values. So it'd be skew to the right because we have a tail to the right. So this would be skewed right if we include the outliers. I would really not call this skewed right now because again, you can look at the difference if you like. To be very clear, 73 to 52, that is a what? 21-point difference. Difference between here to here is 16. So 16, 21, they're not that far apart. So these lengths are not that far apart from each other. And so there's really not much of a skew. All right, we did it for the females. I would love to have the data for the males and look at that pattern of the box plot. So we got the male data, highlight the male numbers only, insert, recommended. Once again, no box plot, no problem. We all know where it is now under all charts, box and whiskers, and there it is. Click on that. And of course, I put it too low, so now we have to move it up slowly to the top. That's why you should always go back to the top before you put the picture in, because now you have to move it up. And this is important to show you what happens. So when it happens to you, you see that sometimes you have to move the chart around, and that's all I'm doing is moving the chart up slowly, slowly till we get up to where I want it. Now, in fact, I want to compare male to female. I can do this now because I have box plots signifying male age and female age. I was able to do this because of what I brought over from the raw set. From the raw set, I brought over gender and age. Before you build your box plots, you got to understand what box plot you want. Do you want just an overall age box plot? There you go. Do you want a box plot filtered by a qualitative category like female or male? You can do that. I would bring over both columns, sort via female and then male, and build your box plots from those. That's the way I do it. All right, we have the numbers once again. Allow me to bring those up so I can see them. Then I'll bring the picture back down. For the male, the minimum is 21. For the male, the quartile 1, hopefully now you're seeing how I'm doing this. The quartile 1 is 37.41. The median is 43.46. Quartile 3 is 51. And the maximum is 70. Please notice, Excel now is seeing, because we filtered it by just male, Excel is now seeing 3 outliers in the male range because of the fact we filtered. When we didn't filter, when we just had age in general, we had 2 outliers. But because we filtered the data, and these 3 are just significantly farther away from the mean than the rest, Excel has pinpointed them as outliers. So that's why they're not in this data set in the box and whisker 5 number summaries. 1, 2, 3, 4, 5 numbers in your 5 number summary. Box plots are very, very useful, and they're very easy to build in Excel. The thing you want to do, and in fact, I'm building this bigger because I'm curious. We actually have a few points that are outliers. I didn't see that before until I stretched it out enough. Notice we have 4 points that are outliers in Excel, according to the male age. This is an important thing to notice. I did not stretch it far enough, so those outliers were all stacked together, and I did not see them. You could have also utilized the fact that Excel is noticing 70 as the maximum for male. If we go down to the male ages, we would have seen a few numbers above 70 and said those are the outliers according to Excel's reasonings. What we have is we've built 3 box plots. Box plots are really, really great when it comes to looking at quantitative data, as you see. What a box plot does, it cuts your universe up into 5 important numbers: the minimum, the maximum, the median, which is the middle number, quartile 1, which cuts off the bottom 25% of the data from the rest, and quartile 3, which cuts off the top 25%. So it really gives me a nice spread, a nice position of age. And then once we have this little table, we can look at similarities and differences. We can say, look, the minimum is the same no matter what. The maximums are slightly different. Now remember, we're looking at age. We're looking at age profiling when it comes to home ownership. So what can we say? Well, we can say the minimum is the same across the board. The minimum home owner in this development, in this neighborhood, is 21. The maximum age is very similar. 70, 71, 73, I would not say is much different. In fact, I really, when I look across, I see no blazing differences, really, when I look across all of these. Bearing in mind, we had some outliers, and those are ones we might look into. Who are the outliers? What do they have in common, right? Now that we've dealt with the general population of male and female, what about these outliers? What do they have in common? What are some ingredients to why their age is important or not important when it comes to our study, if it is? This video is really only about, we have quantitative data. How do you build a picture for quantitative data? The first picture you can build is a box plot. And I've built 3 box plots with you. The key cornerstone to a box plot is the 5-number summary. Thank you guys for watching this video. Stay tuned for the histogram video.